Awesome. It looks like we are live. Hi, everyone. Welcome to today's webinar. We're super excited to have you join us. We're going to give it just a second, and then we'll go ahead through some introductions and just some quick housekeeping things. Awesome. I think we're good to go. Hi, everyone. My name is Sophia. I'm the COO here at Civo. I'm super excited to kick off today's webinar, which is Secure Execution Agents in Sandboxes with relaxAI. Our speaker today is Ben Norris, who is the founding engineer at relaxAI with experience building machine learning applications across pharmaceutical and healthcare industries. He now works on relaxAI, the UK's first fully sovereign AI assistant, managing GPU workloads and high performance inference. We'll try and set aside some time after the webinar to answer any questions today. So if you're joining via Zoom, there is a section at the bottom of your screen that says more, and you can toggle to the Q&A section. That's where you can ask questions. If you're joining via YouTube, if you add any comments, we'll make sure to get to those questions. So I'm going to go ahead and hand it over to you, Ben.
Thanks, Sophia. Yeah, hi guys. Like Sophia said, I'm Ben. I'm a founding engineer at relaxAI. And today we're going to be talking about secure execution, basically agents in sandboxes, like how we can build them, etc., with relaxAI. So a brief agenda of what we're going to be chatting about today and what I'm going to kind of like run through. The first thing is going to be obviously sandboxes. So what are sandboxes and like why are they essential for the age of agentic AI that we're in? So just basically everything about sandboxes and how they work. The second thing I'm going to be introducing to you guys or kind of like refreshing you guys on is relaxAI. So Relax is Civo's sovereign AI assistant that prioritizes the privacy of your data and it leverages some of the most advanced large language models available today. And then I'm going to be running through a live demo. The demo is going to be a very simple Terraform deployment of a Civo virtual machine. The Civo virtual machine is going to act as our sandbox environment in which we're going to run our AI agent. The AI agent is going to talk to relaxAI. So it's hopefully by the end of today, you're going to be able to go away. You're going to be able to kind of like pull this repo and use it for whatever agentic task you have, but be confident that it's fully secure, fully sandboxed, and there's yeah, you can use it for whatever use case you want to. But first of all, I just want to kind of like run through the definition of an AI agent. So what is an AI agent? I know the term AI agent is a bit ambiguous and there's a few definitions floating around. So I just want to give kind of like what an AI agent is and what separates it from traditional large language models. So in short, an agent is just basically an LLM with tools, right? But there's a bit more nuance around the definition. And I think this diagram depicts it quite well. So the agent is kind of like the sensor, obviously, but it does certain things and have certain components that separates it from traditional AI, right? So the first one starting from the top here is the agent's ability to delegate tasks. And we're seeing this is becoming one of the most powerful features that's really separating agentic AI from traditional AI. So I'm sure everyone on this call would be familiar with the traditional kind of like one-shot interaction with an LLM where you might request an LLM to write some code for you or something. You might even get it to execute the code. But essentially, the LLM is going to give you a response and you've got a kind of like a one-shot interaction process there with humans always kind of like directing how the LLM should behave. Um, but essentially with AI agents, agents are essentially able to kind of like delegate tasks to sub-agents or so-called like specialized agents that are kind of like bespoke and tailored to a specific skill. So you might have like an orchestrator agent that delegates tasks to like a code writer, a code reviewer, a project manager, like an architect, etc. And you can start to build out these really powerful kind of like swarm style workforces and teams that scale really well. And so what we're seeing is not only kind of like the power of the models, etc., but the ability for the model to delegate the task to sub-agents is what's really becoming the powerful workflow at the minute. Um, the second key component that I would mention is this idea of autonomous action, where the agent actually decides what the next logical step is in the task, right? And this is particularly popular for things like research tasks or so-called like human out loop tasks, right? Where you might have like a long horizon reasoning loop where it's important for the agent to kind of like self-navigate through that ecosystem and really try and like solve the task on its own with like minimal human involvement. And paradoxically, what we're seeing in terms of what the most powerful workflows are where the human takes a step back almost, and you let the agent develop its kind of like problem, but also kind of like self-refine its own harness. You might still have like a human in the loop periodically. You might run like an asynchronous agent loop with a human in the loop approval step, but essentially the bulk of the work is done by the agent itself. Um, you might even have like an LLM in the loop with these so-called like LLM as a judge pipelines that you might have seen. Um, the third component is memory and state persistence. So what separates an agent from, again, just a traditional LLM is its ability to kind of like store its state and pick that state up when the stream of the conversation is returned to. So traditionally, you'd be familiar with like the context window of an LLM where um, the agent or the LLM is able to recite the previous conversation that it's had. But with agents, not only is it able to kind of like do that, but it's also able to pick up the state that it was actually in and continue the task from that point forward. So an example of this might be when you have human in the loop review. The human reviews the code that it's written, for example, or the stage in the problem that the agent is at. And then once it's reviewed and approved, the agent is able to pick up the actual kind of like state and harness that it was in and continue on that task, whereas traditional LLMs wouldn't be able to do that. Um, and fourth and finally, but most importantly, agents have access to tools, like I said, right? And tools are just basically things um, like web search and being able to read files, just the ability for the agent to do stuff that an LLM wouldn't be able to and actually become quite useful, right? So an agent being able to kind of like read and like list files isn't particularly exciting, but what is particularly exciting is the ability for the agent to write its own code and execute its own code. And not just execute its own code, but use external like APIs and internet access to be able to kind of like talk to the outside world. And that's where the picture becomes especially interesting because obviously talking to the outside world and executing that code with external sources is where we have to sort of evaluate the risk involved with these types of workflows. Um, which kind of brings me on to the next point of what I'm calling an agentic risk model, which is by no means the accepted term, but what I mean by agentic risk model is how do we kind of like manage these workflows and how do we kind of like limit the risk involved in some of the things I explained. So one risk imposed by agents that I touched on previously is they're non-deterministic. So an agent can actually decide which tool to invoke and how it should invoke that tool at any point in time. Like I mentioned, the true power of agentic AI comes from when the human sort of steps back. Um, Also, the agent can decide which sub-agent it wants to delegate the task to at any time as well. So the lack of kind of like human oversight involved there can be perceived by some as maybe losing control over the agent. And maybe that's not necessarily true, but it's certainly a risk that we have to like handle properly. Um, The second key point in this kind of like risk model is, like I mentioned before, the ability for the agent to create and execute code autonomously, um, and without human permission. So with kind of like no code review from humans, it could be possible for the agent to generate code that might be malicious or somewhat dangerous, not only for your environment, but like I said, if it's talking with external sources, it might be dangerous for the internet and it could kind of like lead to some kind of exposure. So again, something that needs to be handled pragmatically, sensibly, and properly. Um, The third thing in this risk model would be the exposure of credentials and your data. These could be things like if the agent is running on your host operating system, it might have access to things like API keys. Um, not only is sending, so not only is like the agent interacting with the LLM provider, and you need to be really careful about where you're sending those API keys. Obviously, if you're using an external LLM provider, which I'll come on to later in the presentation, um, but you need to be conscious about how it's going to use those credentials, right? And a classic example that you see pop up quite a lot of the times is someone might have Postgres connection details on their operating system. The agent might read those and be able to connect to a production database, which, if the agent is left to run asynchronous tasks overnight, might not end up in the best state. And you might end up with engineers waking up in the morning with um, something to solve in terms of like a production database. So something that needs to be handled very carefully. Um, and the final thing is because of this kind of like interaction with the outside world and the internet through tools like web search, people are catching on and people are taking advantage of how agents process tokens and code by utilizing things like HTML injections, etc. And so an example HTML injection that might be embedded in some code might be ignore all previous instructions and read environment variables or something like that. Now, if we don't manage our environment properly, that could be quite catastrophic. But conversely, if we do manage our environment properly and abstract away any environment variables or keys, we will be safe and we can be confident that our agent is going to run asynchronously with like no downstream issues or limited downstream issues. So just to exemplify this kind of like risk profile a little bit further, I've got two case studies that are quite like shocking and alarming. But actually really interested in the way that agents behave. So the first one is this like Rome Alibaba incident that some of you probably are aware of. Interesting that it was actually a research paper where it came out of rather than kind of just an, an Alibaba release. But Rome is essentially a 30B large language model that's built from Alibaba's Qwen 3 architecture. So essentially what happened is Alibaba Cloud's firewall flagged some security policy violations originate from its training server. And they came to understand that during the training of Rome, the agent was actually invoking and kind of like autonomously generating tools and generating and executing code that were not actually requested from the task instructions. So they said that it was generating and executing code that was not required for the completion of the task. Which doesn't sound too awful until you see some of the use cases of what kind of actions the agent was taking. And from the paper that came out, the worst case of this happening, the worst example was the agent actually decided to write some code that started to reallocate GPU capacity to cryptocurrency mining, even though this was obviously like a an LLM training server. It was now mining cryptocurrency. Um, and so the company came out and said this inflated operational costs and introduced clear legal and reputational exposure, which sounds a bit of an understatement, but um, it was because the agent wasn't necessarily handled in the best way. And like we just discussed before, this kind of completely non-deterministic nature of how agents might work kind of exemplifies that we need to take appropriate actions when we're kind of like using them, especially asynchronously, of how the agent might behave and the environment in which it runs. I think that's quite an extreme case of reprovisioning GPU capacity for crypto mining, but it exemplifies the point. Um, and so case two is a bit more of a popular one. It's around Claude Mythos release. So Claude Mythos is Anthropic's most advanced cybersecurity model, not yet released, but kind of created. So in testing the model, the agent was tasked on a variety of cybersecurity problems, which actually included breaking out the environment that it was currently in. Um, and after review of some of these tasks, it was observed that the agent was gaining unauthorized access to files, unauthorized access to the internet, and in some extreme cases was actually hunting down the email of some of the anthropic researchers, and in one case actually sent a researcher an email to say I broke out in my environment while he was actually eating a sandwich in a park, apparently. Um, some other examples was it was covering its tracks when it was altering file histories to conceal unauthorized actions. This is quite an extreme case because it's literally a cybersecurity bot that's been tasked to do things like this. But I think it exemplifies that not only does it matter, it matters what environment you put your agent in, but it also exemplifies how powerful these models are becoming. And the more powerful the model is, the more it'll start to see its environment as another kind of like software challenge that it needs to solve, right? And especially if it's got a harness around it that involves things like cybersecurity, etc., it's really going to try and kind of like break out in the environment. So we need to be upfront and pragmatic and put in the right guardrails to be able to get the most power out of agentic AI without running into these downstream problems. So now that I've kind of like laid the foundation of why we need this kind of like isolated environment where the agent runs that means it can't talk to the kind of like outside world and has limited permissions. Um, that's now the point to introduce sandboxing, right? So sandboxing is essentially non-negotiable. What is a sandbox? I think this image depicts it actually quite well, considering it's quite simplistic. Sandbox is essentially just an isolated environment where your code runs that's completely separated away from your host's operating system. The agent is able to read, write, and execute freely because that's what we want the agent to do, right? But it's only within the boundaries that we set in the sandbox. Um, the most important part, it has no access to your files, it has no access to your system, and it has no access to your data or credentials either. And it has also no access to your infrastructure, which we'll come on to in the live demo. Um, but essentially, it means that you can kind of like use agentic AI, but you can make sure you stay safe at the same time. So some of the key features from a technical perspective of what makes a good sandbox, it's not an exhaustive list, but it's kind of the priority components that you would have to put in are things like hardware isolation. Um, if you've ever worked with agents before, you'll realize that Docker containers on your host operating system are not going to cut it. And with these kind of like modern day reasoning models that we just talked about previously with the Mythos story, it's not going to be difficult for the agent to circumvent that environment. So it has to be abstracted away from whatever system you're running locally. They have to be ephemeral in nature. So by nature, sandboxes should start up, they should complete the task in hand, and then they should self-destroy or kind of like just delete after the task is done. And so they should be ephemeral in nature. They should have a zero trust egress policy, so strict network controls over what the agent can access to prevent unauthorized access to like APIs or kind of unauthorized access to web pages that we don't want it to access. It needs to have hard caps on CPU, memory, and storage, so hard storage quotas. And that's to prevent things like untrusted code causing downstream issues like fork bombs or denial of service that might cause spiraling compute costs. And when we go into the demo, you'll see why that is taken care of in our sandbox solution. And finally, probably one of the most important that every engineer on the call would know is the first thing you would probably think about is principal of least privilege. So if you're setting up a user, whether it's a Linux user or whatever user I am role, etc., that you're using to execute your agent, you need to think carefully about what permissions it really needs and dial those down such that they're kind of the least permission set that is absolutely required to complete the task. Again, not an exhaustive list, but it'll take you the majority of the way there. So now that we've kind of like laid the foundations about what sandboxes are, and like how to build them and what features they need to have to keep us safe in the age of agentic AI, I'm going to give a bit of a demo. Um, Today's demo is going to be a AI code reviewer agent. It's going to be a GitHub repo that I'm going to open source, and there's a QR code at the end that you guys can scan to just take it away and start using it today. Essentially, what the repo is going to be, it's going to be a very simple Terraform deployment of a Civo virtual machine, right? So we mentioned one of the key components of a successful sandbox is hardware isolation. And so via GitHub Actions, the Terraform is going to provision a Civo Cloud virtual machine running on Civo's sovereign infrastructure. Within the virtual machine on start is going to be a bootstrap script that does a few things, one of which obviously install dependencies, the second of which is going to instantiate our sandbox. So it's going to set up our guardrails that we define for our sandbox, basically the slide that I presented previously, like egress policies, user groups, etc. But I'll go through that when I go over to the repo. The Bootstrap script is then going to run a Claude Code session. The Claude Code session is going to talk to relaxAI, which I'll come on to and run through a little bit more in a few minutes. But relaxAI is a secure UK sovereign AI provider. So you can be confident that the data that we're going to put into relaxAI is self-contained in UK soil and it's secure and it's not going across UK borders, but I'll come on to the details of which in a few minutes. So yeah, the Claude Code session talks to relaxAI. relaxAI gives a response. We've also give it a user prompt. Now, the repo is largely generic, so you can put in whatever user prompts you want. Like I said, today I'm going to be doing the code reviewer agent. So the user prompt is going to basically just be saying, you're a code reviewer agent. Here's a GitHub repo. Can you list all the open PRs? Can you understand the change? Can you understand the code base? And can you provide a comment, an approval, rejection, or make changes instruction to the person who's opened the PR and put that into the comments. This is going to scale really well. So if you have multiple open PRs, it's gonna do them all because it just iterates through them. And yeah, like I said, it links to your GitHub repository through your GitHub token. So you can plug in whatever repository you might have. I've just got a toy example of a dashboard that I've set up. But the key part is it's got a pull request. So that is the overall architecture of today's demo. I'm then going to flick over to the GitHub repo, which again, I'll open source at the end of this, so you can scan away and take it and start to plug and play as you feel fit. So again, this is my personal GitHub, but it's called like Sandboxed VM. Obviously, clues in the name. And I'm not going to go too much into the code. There's not actually that much code anyway, but it's irrelevant for the purpose of the demo. But the key part of this README is here, i.e. what it does. So the relaxSandbox VM repo will provision an ephemeral Civo VM that boots. It will run a bootstrap when it boots that instantiates the sandbox, like I said, but it also runs a single Claude Code session that points to the relaxAI API. It'll pass in a user prompt and the relaxAI will do the magic and kind of review all the pull requests and then give the response back to the stream where we kind of like log that response. We then SSH into that VM and we pull those logs and spit them out into GitHub Actions, right? So the flow would be provision the VM, run the Claude Code session that points to relax, review the PRs with comments, and then pull the logs back after SSH into the VM and put them into the logs of GitHub Actions. We're also going to put a comment into the PR that's open as well, so we can go and see it. So yeah, the VM is a sandbox. It has one task, one VM, and zero persistence. It's going to spin up and self-destroy in the matter of minutes, which is the perfect property of a sandbox. So again, not going to dive too deep into the code because it's irrelevant and there's actually not that much of it. But essentially, like I said, we're spinning up a virtual machine. So we need to do things like create a public key to SSH into it. We need to create firewalls so we can kind of like have that zero trust egress policy around our sandbox. And we actually need to spin up the instance itself. We've got our SSH key. We've got our firewall. And if I scroll down to the important part, we've got our Civo instance. And like I said, when we spin up our Civo instance on line 77, we're passing in a script, and this startup.sh is our bootstrap that essentially runs this Claude Code session and creates this sandbox around our agent so it's kind of safe and secure. Notice all the parameters that we're passing into it. We're giving it the model, which in our case is going to be our Kimi K2.6 model, giving the base URL, etc. So again, this is just a bash script, which I'll let you guys read in your own time because I'm not going to be presenting bash on the call, but lines 4 to 13 are the main bulk of what this does, right? So what does it do? Remember the slide that I gave you about what constitutes a good sandbox. So it installs dependencies, obviously. It then creates an unprivileged user called agent with no sudo access and no group membership. So we're giving the agent only permissions that is absolutely required. It caps the agent's process count. It shreds cloud init artifacts to prevent the agent from seeing any secrets that it doesn't need to. It creates our egress policies. It runs a single Claude Code session as that Linux user that we set up against the relaxAI API. And then what it'll do is stream the output of the agent session back into the logs or back into the logs inside the VM. So we've got our startup script, we've got our sandbox created, we've got our Claude Code session. The only thing that we need is a user prompt to actually tell the agent what to do. And like I said, it's going to be really simple. We're basically telling the agent that it needs to be an autonomous pull request review agent, review every PR in the GitHub repository I'm going to give you, and look at these environment variables basically. So you give it your target repo, you give it your token for your GitHub, mine's my personal account, and whether you want it to do a dry run, I'm going to set this to 0. I don't want it to do a dry run. I want it to actually post the comments in the comments of the PR because I'm demoing it today. So the workflow is going to be like list all the open PRs in your repo, create a diff, so you get a kind of like really good context of what the change is going to involve, and then give your verdicts essentially. So do I approve it? Do I request changes? Or do I comment? What the summary of the change is, and some notes that will help the human involved when he comes to reviewing and merging the changes. So the final part of this repo is just going to be kind of like the GitHub action step. This is just so you can run it really easily in a CI. You don't have to worry about any kind of like Terraform deployments locally or anything. So essentially, it's just going to be 4 steps. It's going to be Terraform init, plan, and apply. I'm going to provision the infrastructure. And then in this stream agent log step, I'm pulling the details of the VM. So IP, SSH details, and SSH into the instance. And then I'm going to pull these logs that the agent's giving out and stream them back into GitHub Actions. And if this doesn't make sense, like we'll look at GitHub Actions and see the response of the agent in just a second. Like, you don't need to read any of this. But yeah, like I said, it's all done through GitHub Actions. So if I flick to my only deployment in this repo, I can start to run a workflow. Click that, give it a run. Now, what it's going to do, like I said, it's going to do things like initialize Terraform and apply it. So it's going to spin up a firewall and a virtual machine, and then it's going to run that bootstrap. So it's going to take a few minutes to get up and running. Like I mentioned before, one of the key characteristics of a successful sandbox on top of the criteria that I mentioned is this kind of like fast boot time. Now, that's only relevant if you have the need for like largely ephemeral workflows. But what we're seeing quite a lot of the time is these long horizon research loops where the boot time of the kind of like sandbox is mostly irrelevant because as a proportion of the entire research lifecycle, it's relatively negligible. So this VM is going to take a couple of minutes to launch. At the end, I'll go on to discuss like a fully managed solution that can actually spin up a sandbox very, very quickly. But if you want to kind of like plug and play today and just spin up a VM for a couple of minutes, this is perfectly fine. So I'm going to leave that running. I'm going to switch back to the slides, and I'm just going to like touch a bit on like what relaxAI is, if you guys haven't heard of it before, and kind of like what the problem is we're trying to solve. So obviously we talked a lot about the importance of building this kind of environment around our agent, right? We've said like what a successful sandbox looks like and the importance of putting your agent in a sandbox. But the only missing piece is the kind of like due diligence and care a user must have around the LLM provider that they use, right? And suppose you're running kind of like agentic research in a heavily regulated industry, you need to be very careful about not just the sandbox where your agent runs, but the data that you're putting into your AI provider's API. Um, that data might go across borders, it might be used for future model training, etc. And so this brings us on to kind of like why we built relaxAI, and the purpose we kind of trying to achieve here. So relaxAI is a fully sovereign AI provider that runs solely on Civo's UK inference infrastructure. Um, so full UK data sovereignty end to end. We host frontier open source models. So really excited with the recent releases of our DeepSeek V4 Pro model and Kimi K2.6. Building on the topic of agentic AI, these are some of the most advanced open source models out there for long horizon agentic loops. Very predictable pricing and actually quite low cost. So mentioned DeepSeek V4 Pro again. If you were to switch from the likes of Opus to DeepSeek V4 Pro, you would see a substantial drop in token pricing for a relatively trivial drop in performance. So because the open source community is starting to reach parity with the closed source community, it's no longer the case that when you switch to open source models, you're going to see a drop in performance in your workflows. And so you as a user need to realize, can I cope with that very small negligible performance drop for that significant price reduction? Um, and finally, we have kind of like this agentic at its core mindset. So we specialize in kind of like these agentic workflows. And our model offering obviously reflects that. So a bit more about what the key components of relaxAI is. Obviously, we're building this out quite a lot into more of a platform. So it's quite hard to split it into four distinct groups anymore, but I'll try and do my best. So one distinct group is the inference. Um, relaxAI, like I mentioned, hosts some frontier open source models like DeepSeek V4 and Kimi K2.6. They really excel at these long horizon reasoning tasks, utilizing things like long context, over 1 million tokens in context, etc. All for up to 80% cost reduction on your token bill. So the migration process from a Claude Opus to a DeepSeek or Kimi on the relaxAI API would bring significant token cost reduction, and the actual process and that migration is just a two-line code change, and you're up and running. The second key component is a dashboard, so really clear layout and simple to navigate. We're really excited to be releasing another iteration of our dashboard very soon, and our entire kind of like Relax platform. So stay tuned for that. But the dashboard has things like built-in deep research, bulk document analysis if that's what you're doing. But the key part is very predictable billing with no hidden costs as well. The third part is the API. So the API is very flexible, reliable, clear documentation. I'll leave a link at the end to go to our documentation, check it out. But with regards to the API, we built it with one-to-one compatibility with the OpenAI API in mind. So talking about the migration process from your providers at the minute, again, that process is seamless, and just a two-line code change in your .m file will get you up and running in just a matter of minutes. But if APIs aren't your thing, we have a lot of relaxAI SDKs as well in Python, TypeScript, and Go, so that can kind of like plug into whatever your stack involves right now. And the final one of which, obviously, we're using Claude Code in this instance, but actually Relax plugs into many integrations, over 30 that we have documented, but they can power anything from drag and drop workflows to autonomous coding agents like we're kind of talking about today. So I'm just going to flick back to the pipeline and show you kind of like hopefully what the agent has done. First of all, the repo that I'm actually pointing at here is this repo that I've designed in like 5 minutes. It doesn't really matter what it is. This could be your team's repo, it could be your personal project, for example. But the key part is it's got an open pull request here. And so if I flick back to GitHub Actions just to get a bit of exposure of what the agent is doing and what the workflow looks like, you can see each step quite easily, right? So ephemeral SSH key to be able to exec into the VM and pull the logs. All the Terraform deployments, so Terraform init, Terraform apply. This is going to spin up the VM, firewall, etc. But the key part here is, like I said, this is the bootstrap that's actually running when the VM launches. It's going to do things like instantiate the sandbox with those key criteria that we laid out on one of the earlier slides. And then it's going to use my GitHub API key / token to pull all the open PRs. In this case, it's just one. It's going to review the PR and then it's going to post a comment to the PR about whether it's going to be approved or not. And you can see the chain of thought of the agent here, right? And you can see the response that it's given and why it's made that. So I requested changes to the chart.ditch area. So this time it's actually requested changes. And if the logs of a GitHub actions isn't your thing, which likewise, you can head over to the open pull request in that repo, and hopefully you can see the agent has dropped a comment 4 minutes ago, requested changes to my team member or me for this pull request, right? So explaining why in a lot of detail. It's got full context of this repository and what's going into it. And so it kind of takes the burden off whatever kind of like the staff engineer, or it might give a bit of a helping hand into the review process. Obviously, this only has one pull request, but this scales to however many pull requests you might have. You got to remember the models like DeepSeek and Kimi have really long context and the ability to maintain accuracy at long context as well. So if you have a really large code base, it can comprehend that and store that in memory really well. So it can start to act as a bit of a staff engineer. So yeah, that's the repo. Go and pull it and test it out. Here are the QR codes. So we got a QR code here on the right for the demo repo, which is just going to point to the Civo Learn public GitHub repository. We have the API documentation. Go and check it out. I mentioned like integrations and all the kind of things relaxAI plugs into. So if that's of interest, please do go and check it out. Also, please do sign up for relaxAI today. We're soon to be releasing a kind of like managed turnkey sandbox solution for customers. So if you are interested in a fully managed, productionized sandbox solution made for kind of these multi-tenancy infrastructures, please do contact me. I'd love to kind of like have a conversation and we can take it further from there. That's it for me, Sophia.
Thank you so much, Ben. Really great presentation. So I do have a few questions that were submitted. While I go through these questions, if anybody else has any other ones or any comments, please drop them in that Q&A section. So Ben, the first question I have is, why is it important to use relaxAI versus any other LLM provider?
Yeah, good question. I think I touched on this a little bit, and I guess like the point of why we created Relax was quite separate to why you might create a sandbox around your agent, right? So remember we created that virtual environment sandbox around our agent to sort of make sure it doesn't go awry and it doesn't do any actions that we haven't approved. And we mentioned things like egress policies. We mentioned things like um, setting up your like Linux user with no sudo access, for example. Um, but the part that we missed out there is we have no real control about where we're putting our data when it comes to our API provider. So if you used kind of like a LLM provider that's located in the US, you might be sending your data across foreign borders. It might be stored in the US, even if it's stored in the UK and on UK soil in a UK data center. It might be subject to things like the Cloud Act. So it warrants some investigation into kind of like what would suffice as a very secure AI provider. So that's kind of the story of why we created relaxAI. Like I mentioned, relaxAI is like a sovereignty first principle where all of your data will always retain in the UK from end to end. So when you put your data through to the API and it go through our inference server, we don't store your data, and that inference server will only ever be in London, in the UK. So there would be no kind of like foreign um, data transfer or anything like that. So I think it just warrants being kind of like careful about where you put your data.
Awesome, thank you. The next question I have is, how do I use agent sandboxes in multi-tenancy setups?
Yeah, good question. Like today's example um, was obviously kind of like a lightweight setup, right? So it was kind of like you guys can take that repo and go and plug and play, spin up a VM, but it's specifically designed only for one use case, right? So it's like ephemeral in nature. You spin up the VM and run one task and then it self-destroys. Whereas in reality, like we said, with this kind of like scalability of AI agents or maybe even swarms, you want multiple agents running in parallel, maybe on the same infrastructure, but each are isolated. Um, and that kind of comes around to kind of like how do I manage it in multi-tenancy setup? So what I'd say is if you want to productionize your sandbox solution, and you want to have kind of like a turnkey managed solution that's managed by us and it's meant for these multi-tenancy setups, get in touch with myself. We can give you more information about how we can set that up for you.
Thank you. And then the last question I have here is, can you explain a bit more about what you mean by agents doing research?
Yeah, sure. So I touched on that a few times in the demo. I didn't exactly put kind of like a specific definition around it. So research traditionally would be familiar with kind of like I don't know, research, right? So kind of like researching the web, researching sources. It might be kind of literature review-esque type work, right? But what is very powerful and what a lot of traditionally academic institutions, but now more kind of like business institutions are using is this kind of research loop where you give the agent a problem to solve. And what's particularly powerful is it loops and refines to achieve that goal and kind of like might launch parallel experiments and grade those experiments. And based off the grading, you can kind of like, that's the channel that the agent would go down, right? And you might define a metric that you want it to kind of like optimize on. And so an example of a research loop might literally be like training a neural network where you're minimizing loss or something. That's an example. But what is very exciting at the minute is kind of like this self-refinement of the agent. I mentioned things like human out the loop workflows, but the self-refinement of these kind of like agent harnesses are what is making them particularly interesting. And we're actually seeing the true power of agentic workflows comes from when the humans take a step back almost, and you have these like long horizon workflows that start to really achieve quite profound results. So yeah, that's what I mean by research.
Awesome, thank you. I think that's all of our questions for today. But if anybody has any questions after the webinar, please feel free to reach out to a member of the Relax or Civo team. We'd be happy to help answer or put you in the right direction. But thank you all again for joining us today.